Okay, right. So we have covered the many things in the EIGRP. Let me tell you what we have done in the EIGRP protocol. We have seen the basic of EIGRP, right? And then we went through that all the packet types of the EIGRP, right? Basic packets types of EIGRP. Then we have seen that EIGRP tables, like our neighbor table, adjacency table, and the topology table. Apart from these things, right, these are the major tables we have. Apart from this thing, we have an interface table as well. After that, we have seen the concept of how to advertise the route, right? Advertise the route we can call as a basic topology we have done for the EIGRP. Then we have seen that concept of the what we call route manipulation. In the route manipulation, we have seen the concept of delay, we have seen the concept of bandwidth, we have seen the concept of the offset list, right? And then we have seen that's the offset is used for the selective route manipulation, right? Then after that, we have seen how to do the load balancing. In the load balancing, we have seen the ECMP or unequal post load balancing as well. That's gonna use for the variance command. Then after that, we have seen the concept of the EIGRP stub. Then we have seen the EIGRP named mode, right? And anything else we have covered it? If I'm missing, I think so. And the most important thing, summarization. So summarization, we have seen the concept of the auto summary, and we have seen the concept of the manual summarization, right? And the manual summarization, we have seen that. After that, we have also seen the concept of the redistribution, right? We have seen the route ID concept, right? Many things we have, if you see, we have covered in the last 6 to 7 days of classes, right? And I hope you have learned many things from the EIGRP, right? Something new and something right you have revised if you already know the EIGRP protocol, right? But now the today is a little interesting things I have. Let me open my topology first of all. I have the topology that I'm looking for right now? One minute. Yeah. So the today that we're going to learn the technology is very important. The name of the technology is called what? It's called as an access list. Okay, let me go through my keyword. So access list. So as the name suggests that if you have a look at the name of this guy, access list, right? Or you can call as a IP access list. Anything is fine, right? So if I'm going to break this word in a simple way, I can call as access and I can call as a list of them. List is a what? List is a collection of things. So my mic is on, please disable the mic. Collection of things, and then access is what? Access is something like you want to provide it. So access, either you can give the deny or the permit, right? Access the something. Access is something that please be on mute. Access is something that you can provide. Provide in the sense of either you can see the access will be denied or either access will be the permit. Now, where I can use the access list? See, in the production network, you know what happened? It's by default, when I'm going to run the router agent, we take example, we have router 1 and router 2, and we have router 3 as well. So when I'm going to configure the EIGRP in this case, what happened? I have some few users over there, user number 1, user number 2, and user number 3 over there. So take example, right? I have few users behind the router 3, right? And I have a few users behind the router number 2. So understand the concept. These are the management PC, right? These are the basically a management PC. So in this management network, what happened? These are the settings of management network. So normally, if you're just going to configure the EIGRP, and these are my normal users, right? So normally what happened? All the users can communicate with the management and management can communicate with the users. That's a default behavior, right? That's the meaning of the routing, right? Routing means what? I can exchange the route, router will exchange the route, and they will provide the connectivity. And that's how the management can communicate with the users. But normally what happened in production network, what happened? We don't want to share my traffic between the management and the user. I'm going to say that, okay, the management can only communicate with this guy, and this manager can only communicate with this guy. This manager should not communicate with these 3 persons, right? So I'm going to allow certain traffic, understand the concept. I'm going to allow certain traffic, and I would not deny, and I want to deny certain traffic. So in a production network, I'm telling you, will see the huge list of the ACL. You will see the huge list of the access list. Every production network has the access list. So when I'm going to say the deny, for example, I say the hey, one should not communicate with the 2.2.2.1.1. So when I say the 1.1.1 should not communicate with the 2.1, and say the same thing, 1.1.1 should not communicate with the 3.1.1.1. This is what I'm doing that. Understand the concept. I'm saying that 1.1.1 should not communicate with the 2.2.1 and 1.1.1 should not communicate with the 3.1.1. So I'm saying a deny what? 1.1.1 to 1.1. Sorry. Deny what? 2.1.1.1. Same thing, 1.1.1 should be denied with 3.1.1.1. So I'm putting this statement on the router side. These are basically what? These are my rules. These are my rules that I'm going to define on the router side. So when I'm going to put this rule on the router side, whenever the router will receive the packet, he said, hey, okay. This guy saying, hey, when the packet is coming from the 1.1 source and destination is 2.1.1, let me drop it. When the packet is coming with the 1.1.1, destination 3.1.1, let me drop it. But when the packet is coming with the 1.1.1 and destination 8.8.8, let me allow it. So these are the rules that I'm going to create on the router side. And to create this rule, what we have to do that we need to take a help of the access list. So access list is basically it's combination of the two things. Either you have a standard ACL, right? And either you have a standard ACL. So two types of ACL you have, right? In a standard ACL, we have a 1 to 99 range. So if I'm using the range any from the 1 to 99, that's called as a standard ACL. In the standard ACL, what happened? The range start with the 100 to 199. So if I'm going to take example, I say, hey, ACL access list number 1, it is going to denote that this is the standard ACL. So if I'm saying the access list number 100, this is going to denote that it's the extended ACL. But apart from things, there is a lots of differences that we'll talk about later, not now. But yeah, there's a lots of difference. Basic difference is what the number say. If I'm going to use the number from this range, standard. If I'm going to use the number from this range, go with the extended. So ACL are the very important part of the network, because based on this part, you're going to allow certain traffic or you're going to deny certain traffic. So let's have a look over there. If you see, this is my topology right now. Let me show you the basic configuration of the EIGRP. What I can do that. You can see that I have a 1.1 IP address, I have a 1.2 IP address, I have a 2.1, and I have a 2.2, 3.1, 3.2, and 3.3. That's my server. And this is my interface IP address is 1.100. That's my network is 12.0. This is my network is 23.0. This my network is 2.0, and this my network is 3.100. Right? So the network over here is a 192.160.1.0/24. Same thing, we have a network over here is what? I have a network over here is what? /24. So normally, let me do the basic configuration of the what we call router. Let me check. Okay, I already have a EIGRP. That's perfectly fine. I'll show you the basic configuration right now. So IP interface brief. If you see, I have a interface configuration, right? And if I'm going to show you the show, I need to use the run command, man. I don't have a section. Oh, section is not going to work over here. I think so. It's not going to work, man. So you need to go with the show run. So all the IP is configured, right? And my basic EIGRP, that's I'm going to advertise my 12.0 subnet and the 1.0 subnet, right? Same thing on the router number 2, if you see. On router 2 as well, if I'm going to put the command show IP interface brief, I can see all my IP interfaces enabled over there. 12.2, 23.2, and 2.100. 3 network I have. So if I'm going to put the command show run, my EIGRP is also there. So auto summary is enabled over there because it's an older version. So I don't have any issue because all are my class full network, right? Same thing on the router 3 right now. On router 3, if you see, I'll say the show IP interface brief. And I say the show run, I can see the EIGRP configuration. So what I can do that, I'll quickly configure all those things in my notepad so that everything will be on the same page. My EIGRP basic stuff, right? And okay, right? I think so. Yesterday I forgot to configure the EIGRP, router EIGRP, one EIGRP stuff. Right, so I'll quickly configure the router on one as the IP address will be interface 0/0 if you see 191.168, right? And /24 interface 0/1. I have a, come on, 12.1/24/ come on, you have this guy, no shutdown. On R2, you can see the same configuration. I'll just copy and paste it. Right, on R2 0/0 will be 12.2 and 0/1 will be 23.2. And then we have a 0/0/1 will be 200. And the 1/0, each 1/0 we have, of course, I have a 23.2. No shut. R3 we have, and R3, if you see that on a 0/0 interface, we have a 3.100, perfect, and a 0/1, I have a 23.3. And how about the EIGRP configuration, guys? On a router one, we need to do the EIGRP like this way. Router EIGRP number one. I said the network will be 12.0, network will be 1.0. Router EIGRP number one, I said the network will be 12.0, and so the network will be 23.0. And 2.0 as well. On router 2, 3 as well, router EIGRP number one, I said the network will be 23.0 and 3.0. So these configurations are already present that I've shown you that now. If you see the IP configuration of the PC number one, I'll quickly show you that. Or already have IP. Same thing if you go on a PC number two, already have IP for this guy as well. The default gateway is also configured. If you go on the two now, right now, all good. Same thing if you go with the PC4, perfect 2.2. And of course, this subnet is a 3.0. So this will be 3.1 will be there. And this guy will be 3.2. And the server, of course, I have 3.3. Come on. Perfect, right? So let's send the traffic. If I'm on a PC, send the traffic from the PC number one to whom? I'm going to send the traffic to the PC number one to the 2.1. Right? So I'm sending the traffic from here to here. All good? 2.2. So now I'm sending the traffic from here to here. And now the 3.0 subnet, right? So let's 3.1. That's this guy now. Then this guy, and so on. Just want to make sure that we have a good communication, right? So please, is it important to add the router ID? Automatically they will take the route ID name. You remember what I told you that? Let me explain you again this thing. So what I told you that the route ID election criteria. So it will first, you have to define the manual that we did last few classes. If you don't define the manual, it will go with the highest loopback interface IP address. And if you don't have a loopback, then it will go with the highest physical interface IP address. So in my case right now, you can see that I haven't defined manual, right? And I don't have a loopback. So the physical interface of the IP address will become the router ID over there. So I haven't defined the manual over there. I don't have any loopback. So the router ID will be the highest physical interface IP. So 12.1 will be the router ID. If you want to look that, show IP HRP topology. Let's see. Come on. Got it?
Okay.
Great. So it's up to you. But yeah, recommendation is always what? Go with the manual. Always when you go in the upcoming higher technology, you will get to know that why it is a recommendation to do that. So normally I totally understand, or whenever you're going to learn this technology CCNA and CCNP, so you feel that okay, why I'm going to configure the manual right now. Even I was like that way, right? But whenever you go in the higher level technology, right, you will get to know that why we need to configure the manual.
Okay.
Manual, of course, stability, nothing else. And let's do the filtering now. So what I'm going to do that, I'm going to block the traffic. So take example. I'm going to block the traffic from here to here. Okay. Not here. Let's do that. Yeah, that's fine. Here to here. I'm going to block this guy. And I'm going to also block, just block this 1.2 or 2.1 only. So what I can do that, I'll simply create the ACL for this guy. So I just told you that. So the number of ACL is what? So you have a 1299. That's called the standard ACL. In the standard ACL, guys, in the standard access list, we have a range is 1 to 99, right? In this standard ACL, the first and most important thing is what? You have to always call the source IP. You have to call the source IP, not the destination IP. So you have to do the filtering, understand the concept in this way. You have to do the filtering based on the source IP. In extended, it allows you to do the filtering based on the source plus destination and plus protocol as well. But standard, you have to do based on the source over there. So what I can do that, I'll simply configure this lab on the router number 1. So I'll get the access list. Right? That's the first command, a knob. And then you need to define what ACL I'm going to use it. Am I going to use the standard or extended? So if I'm going to use the standard, I have to put the name is over there, is 1 over there. This is just an identification of the ACL, because on a single router, you could have a multiple ACL statement. In a production, you will see the almost 200 plus of ACL you can see in the production network. Talking the big production network. Don't say that, okay, law, I have seen my company is just have a 5 to 10 ACL. I have seen the more than 500 ACLs. So access list 1, and then you need to tell the action. What I'm an action allow it? Permit or deny. So if I say the deny, because I want to block it, right? So as a deny, what? Any IP address coming from the 1.1.1. Sorry. And what is the wildcard mask for this guy? Of course, match it, match it, match it, match it. Right? That's all. The last statement, right? I just put the one statement right now. So by default, the statement for this guy have a sequence number 10 over there. Sequence number is just nothing but it's just a identification of the line. So I'll say that 10 over there, 20 over there, 30 over there, 40 over there, 50 over there, 60 over there, 70 over there. These are called what? Sequence number. So I have a ACL number 1, ACL number 2, 3, 4, 5, 6, 7, and go on, so on. So sequence number is just an identification. So the first sequence number, I've just said that 10 over there, ACL number 1. Do you know what happened by default? Right? Automatically what happened? You have a, here is a hidden statement over there. By default, implicit deny is present. By default, implicit deny is present in ACL. And this is hidden. Hidden means what? You cannot see that. So if I'm not going to allow anything, automatically everything will be deny again. So I have to allow the remaining person. I say the access list number 1. I say the permit is what? Anything. Anything. And now after this, creating this ACL statement, the last and the most important part is what? We need to call it. So I just create this ACL. I just create this ACL guy. I need to call this ACL on the interface. Now the question is that on which interface? That's a most interesting concept of the ACL. Most of the people know how to create the ACL. But the things comes in the picture when you have to apply it. Where do I apply it? So when I'm going to use the standard ACL, it is always recommendation to apply nearest to the destination. Nearest to the destination. So if I'm going to send the packet from, because I'm denying to the 2.1 over there. So I need to apply to the nearest of this guy, right? 0/1 or maybe the 0/0 or maybe the it's 1/0. So let's do the command on the, I can do the configuration on the router number 2 as well. So I'll just go on the router 2. I'll say the access list 1, deny. What is the source IP address I'm going to deny it? I say that 1.1 wildcard bits, done. Access list 1 permit any. So now what? I need to apply it. So I'll just go on the interface 0/0. Try to understand when the packet comes over here, right? It will become an inbound. For this router perspective, you have to think it. And when it is going out, it will become the outbound. Right? So I just need to apply on which interface. I'll just say that if I'm going to apply on the 0/0, I will call as an inbound. If I'm going to apply on the 0/1, I will call as an outbound. So I'll say the understand, I'll say the 0/0 right now. And it's the IP access group 1 inbound. So the IP means what? I'm doing the IPv4 access list. If you have a v6 access list, then you need to use the v6 command over there. The access group means what? That's I'm going to call the ACL number. In which direction? In the inbound direction. And now if you see the statement, so access list, I have a sequence number 10 and 20 over there. So did I call the 10 sequence? No, I just create the statement like this way. So now what I can do that, I'll just go to the PC number 1. And now if I want to send the traffic to the 2.1, I should not. You can see that? I should not. I can send the traffic to this guy, 1.1 to 1.2. You see, I can send our traffic to the 1.2 as well. But I'm not able to send the traffic to the 2.1. But let's take example. Let's ping from here. PC number 2. To whom? As a PC number 2 to whom? PC number 2 to 2.1. And it should be pingable. The reason is that why? Because I just call the 1.1. Deny it. So when the 1.1 is going on this particular interface, it should be denied. But I haven't denied the 1.2, right? So 1.2 is able to send the traffic, but when the 1.1 is trying to ping to this guy, it should not be. Because over here, I have put the deny statement in the outside direction. If you see, deny host 1.1. So any traffic that is coming with the 1.1, I'll see the denied. So if you see, so access list, previously it was no match. Now I have a match over there. If I'm going to send the next packet, again it will match. So if you go to the laptop 1, again ping it 2.1. So laptop 0. Oh, sorry, 2.1. Which laptop is this? Yeah, 2.1. And destination host receiver, right? So now you can see that again match will be hit over there. So previously it was 8. Now it's come 16 only. Now, if you see, can I send the traffic to this guy now? 3.1. Can you tell me, can I send the traffic to the 3.1? So I'm not able to send the traffic to this guy. Can I be able to send the traffic to this guy? See, even if I'm going to send the traffic to the 2.2, I could not. Let's drop. My question, can I send the traffic to the 3.1? No, you cannot. The reason? Because you have called the ACL on this particular interface as an inbound. Right? So I'm not able to send the traffic, right? Destination host is unreachable. But if I'm going to set the interface, if I'm going to call the ACL on this particular interface 0/1, then I could send the traffic to the 3.1. The reason is that because the ACL is sitting over there, and in this ACL I said, hey, deny what? 1.1. So if any packet is coming to this particular interface, doesn't matter you're sending the traffic to this guy, this guy, this guy, this guy, this guy, all will be denied because the source IP address is what? And in the source IP address, what I called over there, denied. So he's denying everything. So better to use what? What I told you that you need to use the standard ACL nearest to the destination. So this is the destination we have. This is the destination we have. Which is the nearest, this interface or this interface? Of course, this interface, right? So you need to apply the ACL on this guy. Then you can send the traffic to this person, but not to this two guy. So what you can do that, I'll quickly go on the router number 2. I'll remove this guy from the interface 0/0, no IP access group, 1 inbound, and I'm going to apply to the 0/1 IP access group will be 1 outbound. Because now I'm sending it. Now I'm sending it. So now if I'm going to send the traffic to the, again, which guy? 2.1, I could not, of course. Host is unreachable. If I'm going to 2.2, I could not. The host is unreachable. But I could able to send the traffic to the 3.1. Why not? Hold on. One minute, guys. So run interface, so run. Oh, by mistakenly, I have called this 0/1, man. That's ACL apply over there. So the problem I have this interface, right? So both have the same name. 1 minute. But I call. Can you see that? I just applied on the 0/1. It's automatically get applied on the ETH1/0. But how is possible? I manually configure the command 0/1. Not a big deal. It's a hardware issue, guys. Not a hardware issue. It's a packet tracer issue, right? So when I'm calling, let me remove this guy ETH1/0. This is no IP access group. 1 out. And now you can check is it removed or not. Yeah, it's not removed. Perfect. Now I can send it. Perfect, right? Done. But I could not able to send the traffic to the 2.1, but I can send the traffic to the 3.1. So this is how you can use the standard ACL. But if you have a firewall installed, do you still to configure this personal user? So firewall, of course, denying it. But if you don't have a firewall, then you have to do the ACL, right? So firewall, basically the main use case of the firewall is what? To allow and deny the certain traffic. But ACL is a kind of firewall. If you don't have a much budget, you can do the ACL. But it doesn't mean that. It doesn't mean that, because see, firewall are mostly present in the headquarters side, maybe the main branch, headquarter, or maybe the data center network. Not in the every enterprise has a firewall, right? So you have option with the ACL only.
Thank you.
And what your question was that, can I use the ACL?
No,
You already have.
do you still need ACL
I'm coming to the point.
in any case?
Yeah, I'm coming to the point. Just hold on.
Okay.
Yes, we need it. You will see in future. Hold on, you will see that. Don't worry.
Okay, thank you.
So this is how you can do the standard ACL. The problem with the standard ACL is what? See, I'm not saying the problem, man. Everyone is using the standard ACL, like standard ACL, depend on the requirement. So you cannot say that standard is bad or extended is good and extended is bad and standard is bad good, because it's totally depend on those scenarios. I'm telling you, everything in the networking is depend on the scenarios. But let me tell you why we have to go with the standard. So normally the problem with the standard ACL is what? If you see, I'm just matching the things based on what? Source. What I want this guy should not communicate with this guy. Okay, I did it. If you see in my statement, I call this the same person, right? I didn't want one. But the problem is that what? Okay, if you want to block the certain complete network, you can also block it. So for complete network, your ACL should be like this way. Deny will be right. So normally in this case, what happened? If I'm going to block to the 1.1 to the 2.1, then what happened? It also get blocked by this guy as well, because eventually you are matching the source. See, I'm not able to send the traffic to the 2.2 as well. Can you see that? I blocked the 2.1. That's my intention. It's not going to send the traffic, but eventually what happened? I'm not able to send the traffic to the 2.2 as well. That's the biggest issue. Because in the standard, you're always calling the source over there, not the destination. And that's why we came with the concept is called the extended ACL. So in the extended ACL, what happened? Instead of the calling the source, we have to also call the destination as well. So let me remove the ACL, no access list one. And I'm going to remove the ACL from interface. Outbound. So now everything is working. I removed that. So I could send the traffic to the 2.2. Perfect. And I could send the traffic to the 2.1 as well. Working fine. Right? Now let's do the extended. So in the extended, what happened? I just need to go in the router number 2. I'll call this guy access list. The number I should use with the extended is what? 100, right?
100 and over.
So standard is 1 to 99. Standard is 100 plus 199. As the 100, then what? You have to call the three things. Protocol, then source IP, and destination IP. So that's a beauty combination you have with the help of ACL. I see the deny. What I'm going to deny it? I'm going to deny the ICMP protocol, right? Because the ping works on the ICMP protocol. Obviously, the source will be what? 1.1. I need to give the wildcard mask. And for the destination, what I can do that? I know the destination IP is a host IP. Host means what? Single IP. I can use the host keyword. So if I'm going to use the host keyword, in that case, you don't need to give the wildcard mask. And I just say that 2.1. That's all. 100.
Okay.
Permit any. Oh, why you are not working that? Permit IP any. So if you see, I just call the host over there. So let me put this statement on the page, notepad. Let me, the problem, oh, I'm so sorry. The problem of standard issue, again, guys, I'm just writing it for you only. Don't think it's a problem. Okay, in environment, in production network, we are using everything, right? It's depend on the scenarios, right? So the problem with the standard ACL, it blocked the traffic based on source, right? That's a biggest issue. So that's why we came with the concept of called as extended ACL. In the extended ACL, we need to call protocol plus source IP plus destination IP. And here we have access list 100. What I'm gonna do that deny, which protocol I'm gonna deny it? I said the ICMP because ping works on the ICMP protocol, right? And I said the 191.secure.1.1 wildcard mask. Host, I can use the keyword. So in that case, I don't need to use the wildcard mask. And access list 100, format in format IP in IP means what? All the protocols. Whatever the protocols are comes in the IP. Under the IP, whatever your EIGRP comes, OSPF comes, TCP comes, UDP comes, every protocol comes in the IP, right? So I'm allowing everything except the ICMP only for this guy to this guy. So now it's gonna match three things. Whenever the router will receive the packet, it's gonna match three things. So now let's do this thing. Now where you can apply it, it is recommendation to apply nearest to the source. So I can go on the router number 1. Access list 100, deny. Which protocol you want to deny it, man? I want to say the ICMP. I have a bunch of protocol, right? So majorly you can see that most of the protocol you already know that. EIGRP no, right? And ICMP you know, IP protocol is no. IP means what? Any protocol, any internet protocol. OSPF you already know, TCP no, UDP no. GRE is a like a point-to-point VPN comes in the picture. This is ESP and AH. It comes in the IPsec protocol. So deny ICMP, I say the host will be what? On it, make a host. I say the 1.1 wildcard, and a host will be on 2.1. 100 commit any IP any. And I'm gonna apply on each interface. I'll just call the 0/0, man. Even I can call the 0/1 as well. Call the 0/1 IP access group. 100 out. Show access list. Done. Now let's send the packet from here. 2.1. Get unreachable, right? But I should be able to send the traffic with the 2.2, which was not possible in the case of standard. That's a major difference. That's a major difference between the standard or extended ACL. So if you see that in previous case, I was not able to send the traffic to the 2.2, right? If you see, I was pinging the 2.2, but destination was unreachable in the standard. But in the extended, I could able to ping the 2.2. So if you see the match, it's matching. Perfect. Anyone have questions?
Please, in the configuration, you went to the interface.
Router number 1.
Yes, you went to the interface and you added you added access list group.
Yeah, I said the IP access group.
Yes. And okay, by which instant in which instant are we supposed to bring the group?
Which instant? I didn't understand your question. Can you?
Okay. So no, I was saying that like is it that when you are when you want to configure it on the interface itself, you have to start by IP access group.
So you are saying that how I decided to configure on this particular interface?
Yes, because
I can also configure on the 0/0, right? That's you're saying that.
No, okay, okay, because in the first place you were saying that access list one, one either either you deny or or you permit. But then the other one, when you said interface F0/1, you said IP access group 100 out. So that's so I just want to be clear. At which instance are we supposed to use the IP access list group?
Which environment you're asking, or which? Can you put the questions in the chat? I think so. I'm not able to understand your question. Can you put it in the chat, then I can understand it
In which
properly?
instance are we supposed to use the IP access group, IP access list group?
Which what is the meaning of instance you are talking about?
So like like in which case or in other words, I mean, and in other words, and which like which I don't even know the next word I should use. Which scenario? Okay, in which scenario are we supposed to use the IP access list
Okay,
group?
which scenario you're talking? Which scenario I
Yes,
want to use the ACL?
yes,
Oh,
the
got it.
access list group. In
Yeah,
which scenario?
yeah.
Yes.
So, see, normally what happened, I don't want to say. So take example, this is my one of the user, this is the another user is sitting over there, right? And this is the router over there, this is the another router. And take example, this is the switch we have, right? And this is the
Okay.
switch another we have. So take example, these are the manager PCs. So these are the manager PC. These are the manager PC. So normally what happened, this is the sales team, right? So normally what happened, this manager can communicate with the sales and sales can communicate with the manager. There's no issue. There's no foundation actually, right? What I
Okay.
want to do that, I'm gonna block the traffic. I want to say that, hey, manager and manager only can communicate. Other person cannot interrupt me.
Okay.
That's you're gonna use it. So you're gonna allow the certain user, you're not deny the certain user. So requirement is a much requirement. Let me tell you the examination perspective. You can do that. So in examinations, what happened? The users to users should not communicate, but the user to server should communicate, right? I can use the ACL over there as well.
Yeah.
So normally ACLs has a multiple use cases, man. It's just up to you how you can hold the things, right?
Okay. Okay, that's fine. Okay. Understood.
Anyone has a question, guys?
Yes, I have a question. Could you explain a little bit more, because I'm confused with the in and out?
Okay. So tell me one thing. So you have to assume according to the router first of all. Okay. Let's take example. You are sitting on the router number 1. Okay. You just received the packet on this particular interface. So is it called as an inbound or outbound?
I think it's in.
It's incorrect statement. So when I'm going to forward the packet from this interface, then it is called as in or out.
From
Outbound, sir.
Out.
Outbound.
Exactly. So now when I receive this packet on this particular interface, is it called as in or out?
In.
When I'm going to forward this packet from this interface, is it called as in or out?
Out.
Out.
Okay. When I receive this packet on this particular, is it called as in or out?
In.
When you receive it.
In.
It's in.
In.
Am I going to forward the packet from this interface, is it called as in or out?
You are going out.
Out.
And when I'm going to forward the packet from this interface, it's called as in or out?
Out.
In, sir.
भाई जब तुझे सब everything you already know, Boozer.
Yeah, but a little bit confusion. just to make sure.
Yeah. So now I understood.
Yeah. Thank you.
Great. So that's how the ACL. So in the ACL, guys, what we are doing, we are doing the packet filtering. Yeah.
In the ACL, how many sequences are allowed? Is there any limitations?
What do you mean sequence are allowed?
You so told, right? 10, 20, 30.
Yeah,
the list of
yeah. So the exactly the sequence number, I think so it's 32-bit number we have in the sequence number, right? I'm not pretty sure. I remember that, like I was not able to recall it. But yeah, it's a near around 4 byte, or we can say 32-bit number. I'll check it and let you know. Don't worry. Okay.
Okay. Yeah.
But it has a huge number. Okay. It's
Okay.
a huge number. I have seen that.
Okay.
So we have a packet filtering. So the things that we have seen this till now is called as the packet filtering. What do we mean with the packet filtering? In the packet filtering, what happened? If you see, the PC1 should not able to communicate with the PC number 3. But I still have a route in my routing table. If you see that, so IP route, I still have a 2.0 subnet. So in the packet filtering, normally what happened? In a packet filtering, normally what happened? You have a route in your routing table, but you cannot send the traffic. That's the meaning of packet filtering. You have a route in your routing table. So two things are there. One is called as a packet filtering. In packet filtering, what happened? You have a route in your routing table, but you can't send the traffic. I'm not denying it's a bad situation. It's a good situation because in this case, what happened? Understand this case. In this case, I can still send the traffic via this guy. I want it because I just blocked for whom? I just blocked for this guy, right? So in this case, I need a route in my routing table. I need a route in my routing table. But take example, I'll give you one scenario. If I'm also gonna block this guy, then you tell me one thing. I just want to block the complete this 2.0 subnet. You can do that based on the ACL, right? But the problem will be what? You are still gonna maintain the routes in your routing table. Do I really need this route in my routing table? No. If I'm just blocking everyone, so let's remove the route from the routing table. Why you are maintaining the information? If you're gonna maintain the information, you should receive the EIGRP update packet, QD packet, right? If the interface goes down, you need to process it. And of course, this will consume the my router memory as well. This is the one scenario, right? The difference is called a packet filtering. So what I have to do, I just need to remove the route. I just need to remove the unwanted route from the routing table. Remove unwanted routes from the routing table. This is called as what called? This is called as a route filtering. In a route filtering, what happened? We are just gonna remove the route from the routing table. If I'm gonna remove the route from the routing table, then what happened? That's mechanism is called as route filtering. To do the route filtering, we need to still use the ACL. Another example I'm giving you. Normally what happened whenever you took a connection from the service provider, right? So whenever you took the connection from the service provider, what service provider is doing that? Service provider will send you the bunch of route in your routing table. They will send you the 2+K route in your routing table. Do you need this 2K plus route? No. Then why I'm going to accept this route? Because if I'm going to put this route in my routing table, then what happened? My router is going to consume the lots of memory for this route. CPU comes in the picture. And do I need this route information? No, these are the unwanted information. These routes are unwanted information in my routing table. Why should I maintain this information? So what you can do that, you can just block this certain route because these routes are unwanted route for me. So you need to block these certain routes. That's called the route filtering. Route filtering means what? Filter the route from the routing table. That's the meaning of route filtering. Packet filtering is what? Filter the packet, but route still will be there. Route filtering is what? Filter the route from the routing table. And that's a Bhujar has asked me the question, right? So if you already have a firewall, then why do we need a ACL? This is how you need a ACL. Because to do the route filtering, right, you still need a ACL because ASA firewall is not gonna by default it's not doing that. Of course, you can also do the route filtering in the ASA firewall as well, right? I'm not denying it. But default behavior of the ASA firewall is what? It's doing the packet filtering. So to do the route filtering, you still need a ACL over there. So for this thing, I need to open my GNS3. Which you don't want, simply. Do I have a? I do have. Okay, man. Bunch of proud I have on the router number 2. So let me do one thing. Check the IP address. Perfect, I have. Check the IP on this guy. Oh, man. Okay. R2. All good? Done, man. Let's configure the EIGRP on the router number 1. And R2, right? If you see one thing, I configured all the loopbacks on the router number 2, and router number 2 is gonna advertise all this loopback information to the router number 1. Okay. Now, whatever the users are present over there, right? Whatever the users are present over there, they are only interested to send the traffic, right? They are only interested to send the traffic to this network and this network and this network. So user 1 is interested to send the traffic to the 1.1. User 2 is interested to send the traffic to the 2.1. And user 3 is interested to send the traffic to the 3.1 network. But if you check in your routing table, I have a bunch of information. Router or users are sitting behind the router 1. They are only interested to send the traffic to this network, and this network. So for my router, for this router, these are called what? 4, 5, 6, 7. These are called as an unwanted route in my routing table. There is no need. But the problem is that If you're gonna form the EIGRP membership, they will send the complete route to you. You cannot do that anything because this is the service provider, right? They can send all the traffic to you. This is your responsibility. You have to put the border over there. This is your responsibility. You need to put the border over there, and you need to allow the certain network. You need to allow the certain network, not the complete one. You need to block the 4, you need to block the 5, you need to block the 6, and you need to block the 7 over there. So right now, if you check the routing table summary right now, I'm utilizing this amount of memory and this amount of CPU overhead. What I can do that, I'll simply go on the router number 1. I'll see that access list, because I don't have a control on the router number 2. Router number 2 is ISP. You only have a control on the router number 1. So access list, and what I call standard, is it? Okay, format, I'm only gonna allow which person? I'm only gonna allow which person? I'm only gonna allow which person now? Okay, remaining what will be happen? Implicit deny, right? So after creating the ACL, now, if you're gonna apply this ACL on the interface, then what happened? That's called as the packet filtering, right? But in the route filtering, what happened? You need to call the ACL, right? And then you need to apply it under the EIGRP distribute list. Distribute list will help you to call the route filtering. Distribute list will help you to do the route filtering. So I see the distribute list 1, that's an ACL number. And I see the inbound. That's all. So if you're going to use the distribute list on the router number 2, then you need to say the outbound. Because right now the router 1 is receiving the route. That's why I call as inbound. Router 1 is receiving the route. That's why I call as inbound. Copy and paste it. So I'm only going to allow these 3 network automatically. Remaining will be denied. Gone. I can see the memory, man. Previously, it was consuming the 1024. Now, so based on the ACL, right, you can do the packet filtering and you can do the route filtering as well. You could do the same thing as like this way as well if you want, or I can say that. And then you need to the allow the remaining version. Better to use this guy because it has a sort of ACL. Because each ACL statement require amount of memory as well. Let me recap how much it was. Something around like 30 bytes or 50 bytes, something was there. Like I read somewhere, right? In some of the very older books, I read it, right? It was something around here around. Each ACL statement requires some amount of memory, man. So better to use the shorter one. All good? Anyone has a questions? So that's a major difference. In the route filtering, what happened? We are just going to filter the route. In the packet filtering, what happened? The route still will be there, but the certain traffic will be denied. Certain traffic, not the all. But if you are receiving the unwanted information, just deny it. Then do the route filtering. In a route filtering, you're going to apply the ACL on the distribute list. Right. In the case of EIGRP, every protocol has a different behavior. In a packet filtering, you're going to apply the ACL on a per interface basis. Questions? So that's all. Okay. We'll do the. I have a few more things in the route filtering. That's called as the route map concept, and prefix this concept as well. That I will do on the Monday. Okay. Because these things will get confused a little bit more, right? That's why. So we'll do this thing on the Monday, and the Monday we'll finish the EIGRP, and then on Tuesday we are gonna go with the OSPF protocol. Okay. So on the Monday, once we are done with the EIGRP, then I'll share you this notepad. Then you can have all this notepad in a single page. You have all the information.
Okay.
All good, guys. Happy weekend to everybody. If you have a question, you can feel free to ask me. If not, then it's fine. Please turn this. Yeah, sure, Nashid. I'll just turn it on. Okay, guys. Bye-bye. Happy weekend.
All right.
Bye. Thank you.